Alright, so in this video, we're going to prove that the derivative of sine x is cosine x. So how do you suppose that we prove that the derivative of sine is cosine? Well, we could start out by using the definition of a derivative. If you recall, the definition of a derivative can be expressed as a limit, like this. So this is the definition of a derivative, and we're going to replace our function with sine x. So essentially, we need to prove that this limit is equal to cosine of x. So where do we even start? Like, how do we convert this into what we want it to be? Well, we sort of just have to play around with it. Notice that this is really the sine of two things added together. If you recall, there is this identity that tells us the sine of two things added together. This is the identity. And so we're going to apply this identity to sine of x plus h. And so all I've done is I've re-expressed this as this. So then what do we do from here? Well, we're going to continue playing around with it. Notice that these two terms both contain sine x. Therefore, we can group these two terms together and factor out sine x from them. And so this is what we would get if we were to do that. And you could verify that this numerator is identical to this numerator, right? All you'd have to do is distribute and it's identical. So what can we do from here? Well, notice that overall in the numerator, we have the sum of two things. We have this plus this. Well, we can split this fraction up into a sum of two fractions. And so I've re-expressed this fraction as a sum of two fractions. And again, you can verify if you were to add these two fractions together, this would be identical to this, right? Because they both have the same denominator, so it's pretty easy to add them. So what can we do from here? Well, notice that we're taking the limit of something plus something. Well, if you recall, there's this property of limits that says that if you have the limit of something plus something, it's equal to the limit of this plus the limit of this. And so this is what we have now. So the next thing that we're about to do may seem a little weird, but what we're going to do is we're going to pull out the sine x from this limit, and we're going to pull the cosine of x from this limit. But why can we do that? Well, because as h approaches 0, nothing happens to x. Therefore, sine of x is treated as a constant with respect to h approaching 0. Why? Because in the definition of the derivative, as h approaches 0, nothing happens to x. We're just letting h approach 0, but nothing is happening to x. So x is treated as a constant as h approaches 0. Right, so we're just going to pull out sine x from this limit and cosine of x from this limit. So we've pulled out the sine and cosine from the two limits. So now it is just a matter of evaluating these two limits. Now, I made two videos evaluating these two limits. And the answer to this limit is 0. The answer to this limit is 1. Therefore, we have sine x times 0 plus cosine x times 1. That's equal to cosine x. And so there it is. We have shown that the derivative of sine x is equal to cosine x. And so this is it. We have completed the proof. So yeah, that's pretty much it for this video.